Okay, trying something a little bit new here for my people that are out, whether you're quarantined or just you're sick today or whatever. But this is, I'm going to try to keep it as short as possible, but a little video of how the class is going so that maybe you can supplement what you're reading and it's learning with this short video to kind of see how the class is going. So I saw this out, my family was out a couple years ago and boom, do you see it? Do you see it? We were in X Games mode. Can you figure out what would have gone up here? Yeah, that's right. And would have gone up here to make this work? Pause the video for a second and then unpause it after you've figured it out or you're ready for an answer. So, all right, hopefully you paused it and you're back. So, on the top, it's two things that are being multiplied. So that must be r squared. So r squared on top because these two things, then they add to give this bottom one, so it must have been 2r. And if you really wanted to go far with it, what was the original expression, algebraic quadratic trinomial that gave this, that got somebody started on this? It must have been r squared in the beginning, and then the b value was broken up into r plus r, so that would have been 2r. And at the end, well, what would have that c value must have been a plus 1 to make it multiply times r squared to give you the r squared in the x. So if you can figure that out, whew, you're way ahead of the game. If you're like, what are you talking about, Fisher? All I saw was a railroad crossing sign. Hey, take a look at this dots. We went over this in class the other day, but we didn't document it. It's the difference of two squares. Difference of two squares. And today, that's right. See what you're missing in class? Oh, we're getting some dots, all right, in a pandemic safe way. So if you have the difference, and they're calling it the difference because it has subtraction between two perfect squares, and it will always factor, if you have the difference of two perfect squares, into the square root of the first term in the beginning of each binomial, plus and minus the square root of the second term. And so today in class, we're going to fill this out. Think of x squared minus 64 as x squared minus 8 squared. Now you kind of have the square root of the first term and the square root of the second term. So x squared minus 64 factors to x plus 8, x minus 8. You can do this, and I'll leave this, well, 4x squared is, think of it as 2x times itself. And 81 is like 9 squared, so that gives you 2x plus 9, and 2x minus 9. You can factor with the diamond if you really want to, right? But nobody wants to if they can figure it out and they can go straight down to the answer over here, okay? But if you really have to, you can put a 0x in the b term in the middle because it's missing, and then you can fill out using the a, b, and c. A times c in this case is negative 100, and the b value for the basement is 0. Two things that multiply to give 100 is 10 and 10, but negative 100 is negative 10 and positive 10. Therefore, you would break this up as x squared plus 10x minus 10x minus 100, all right? And eventually you would factor out an x in the beginning there, and because we would group it, and we would group it like that, that's really a plus in there, plus that. So all this is being added so you can group it. Common factor here is x, and x plus 10 is what it leaves. Common factor in this one, sorry, I didn't leave myself some room, is, oh, wait a minute, sorry, it's negative 10, and I'd be left with x and negative 10. Oh, it'd have to be plus 10, all right? And therefore, I can pull these two terms out, and that's x minus 10, and the common term in there was x plus 10. And then, that's your answer. We can do the same thing with that one. Or you can just recognize it as dots, difference of two squares, and go, hey, square root of the first term, x, and then plus or minus the square root of the second term, 10, and negative 10. Woo! All right, we could prove it, but this is a short video for those that are stuck at home today. We could document it over here in this whole decision tree for factoring quadratics. We documented this one and this one using the GCF, the ABC, and the X Games mode is what I was talking about. And here, this is just called dots. And if we recognize it as the difference of two squares, we don't need to go through that, but we could. And then we just say, hey, that's the square root of the first term, plus and minus, always plus and minus, and the square root of the second term. And we can get around going through that whole process. Nice. And then this one over here, x squared plus 25. The point I wanted to make here is there's no such thing as sots. I mean, I went to the grocery store to buy some sots, but all I could find was the dots. So it starts with the D, that's the difference of two squares. Well, this one is the sum of two perfect squares. It doesn't factor. Okay, that's like, no, you can't do it. No, 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 no. Okay, so we're just recognizing that this one we would actually just say NF, not for North Forsyth, but for not factorable. All right, not factorable. And we'll find things like that occasionally. All right, next thing, I'm at 6 minutes. Take a quiz on Delta Math. If you're home today and your class is today, the quiz is available on Delta Math. So take that. It's not a big deal. If you don't do well on this quiz, you'll find out immediately afterwards what you didn't do well on. That quiz grade is going to get recorded, but it's going to get replaced by your unit test grade. So just get used to that in my class. Quizzes are probably not going to be announced. Just keep up with the class, and if you don't do well on the unit test. Quizzes are meant to give you an idea of where you are. They're not meant to freak you out. They're meant to, well, if you're not doing well at all, then they're meant to go, hey, you got to get it together before the unit test. So go take that quiz. If you have your class today, it will be available. If you have your class on Monday, take it on Monday. All right. And then just continuing with what we're going to learn today. Here's a sentence that eventually ends in this algebraic equation. Aha, for the first time we're seeing an algebraic equation in this class. And it just says if you multiply 2 more than my favorite number, so apparently x is my favorite number, times 3 less than my favorite number. So apparently this is 3 less than my favorite number. Again, x equals my favorite number. My favorite number. That's what that says. If you multiply those, you get 0. Okay, so what's my favorite number? Well, two things that get multiplied. If you have two numbers that multiply to give 0, there's this thing called the zero product property that says one or both of those things must be 0. And think about it, like 9 times what equals 0? Well, doesn't it have to be 0 right here? Okay, with that logic, then this right here, where we're saying two things are being multiplied to give 0, we're going to learn this idea of splitting this up. Well, either x plus 2 has to be 0, or x minus 3 has to be 0. So if we have two things that are being multiplied to give 0, then we can split it up into these little mini equations, and then they're super easy to solve. I'm just going to subtract 2 from both sides. I get x equals -2. So my favorite number could be -2. Or my favorite number, and get used to this, when we have an x squared, we're going to find 2 possible answers in most cases. All right. So in this little mini equation, I'm going to add 3 to both sides, and I get x equals 3. So the best I can say at this point is my favorite number could be 3, or it could be -2. And you pretty much just learned how we're going to handle solving equations for quadratics. We're going to, not ready for that learning card yet. All right, we're going to break it up and set it to 0. And here's a more complicated one, and this lends itself well. If you square my favorite number, here again, x is my favorite number. If you square my favorite number and add 5 times my favorite number and subtract 10, you'll get 4 less than 6 times my favorite number. Or as you guys say, blowing my mind with this ridiculous looking quadratic equation. Well, here's the idea in a nutshell, is we're going to set this equal to 0. And you might remember that was a critical component of this up here, is that it was set to 0. So I'm going to actually subtract 6x. We're used to getting everything, isolating x. Well, in this case, we're going to do a different approach. So we got x squared minus x, I combine those like terms, minus 10 equals -4. These canceled out. Now I'm going to add 4. And a whole new approach to solving equations when they're quadratic. is I've got x squared minus x minus 6 equals 0. And okay, before I said the zero product property was two things multiplied to give 0. Well, this isn't two things multiplied to give 0. But if we go through our factoring process, look for a GCF, there isn't one, use the ABC values, the A, B, and C values to populate the diamond. And we've got A times C is -6, and in the basement we've got -1. And think of two things that multiply to give -6. It turns out it's -3 and +2, but add to -1. Okay, I know I went through that fast, but you've been doing that. That's going to tell us how to break up the B value. So I'm going to go back to this original quadratic equation where we had it set to 0, and I'm going to break up the B value into this using the diamond, and then minus the 6, but all that equals 0. This is a new part right here that is really critical. And then I'm going to group, and I'm going to factor, and I get x and x minus 3 in this one. I'm going fast because you know how to do this now. I get 2 as a common factor here, and I get x minus 3. The x minus 3's are the same, so they're one of the binomials, and the x and the plus 2 got factored out, so that's the other binomial. So, look at this. It is the same as this expression up here. So we're going to use this thing called the zero product property. And when two things are being multiplied, they give 0. You can split them up. X plus 3 equals 0 and x plus 2 equals 0, because the zero product property says if two things are being multiplied and they come out to 0, then either the first thing has to be 0 or the second thing has to be 0. And then we solve these many equations. We find out that x is either equal to -3 or x is equal to, whoops, you saw it. See that minus there? I don't know. That was supposed to be a -3. This should have been +3. So x is equal to 3 or it's equal to -2 when I solve those two different equations. So that's what we're going to do. I'm going to do a separate little video to fill out this learning card, or actually if you want to take a look at, it shows two different examples. If you want to take a look at the filled out version of it, that would be fantastic. I think I'm going to leave it at that. And then after this, we're going to do a Desmos activity here with a partner. I'm going to put up one of those, well, both of those partner sheets. If you want to do half of them, that would be great. Do partner A and partner B and do it on Desmos, and I'll see that you're getting the check marks by selecting both problems. Or you can just pick one of the partner activities and just do it and turn it into me when you get back, or take a picture of it and send it over to me, and I'll let you know if you got them right or not. All right, thanks, and I'm so sorry you're quarantined or you're homesick or you can't be here with us, but thank you for keeping up, and that's it for today. Thank you.